Yeah, I think this is everyone that signed up to present today. And let me just take a look at the thing. And I can also start by giving some quick context for Barlin also, because I think that you have only gotten my messages about the study group, probably haven't heard too much about it, but yeah, I can give a little bit of context. Let me just share my screen. Cool. And I'll walk through the one-stop shop to get started. So yeah, Barlin, welcome to the cadCAD study group. Great to have you. And just for a little bit of background, this is the cadCAD study group. We are working out of this Notion. So this is kind of like our home base for the program, collecting resources, some session notes and stuff. But basically, the whole point of this program.
You're just sharing. You're just sharing like your Infinity Discord. Just so you know.
Okay, sorry. That's what happens when you talk and share screen at the same time.
Yeah.
Okay, thanks for the heads up. Cool. I think that's it. Yep. Can you see the Notion?
Cool. Thank you.
So yeah, the point of this study group, more or less, is to create a space for people to come together and work through, I would say, self-guided or they're individually driven learning journeys related to cadCAD, token engineering, token economic systems. It's kind of ended up as sort of a mix. I think so. The program started about 7 or 8 weeks ago. I think 8 weeks ago now. And we started out with some introduction to cadCAD 1.0 from Tyler, just introducing some of the new concepts like blocks and states and points and dimensions. And so that was really cool to get an intro into that. But then since then, we've kind of more been focusing on system mapping and design of our own individual systems, and haven't actually done too much coding. So I'll just jump into the active participants and learning goals section of the one-stop shop. And this is where you can find some of the ongoing learning goals that participants have had, some of them less active than others. But yeah, there's been kind of a mix of different topics. And Zane has been working on this one here. Quiet Catalyst has been working on liquidity models, and I have two in here actually, this predator-prey model and applied TE process. So those are, I guess, the three we'll probably go over today. But yeah, there's been kind of a mix of topics, and yeah, basically we just sign up independently each week. Anyone who wants to reserve time on the agenda and yeah, sign up and talk about the progress that we made in the past week, and then yeah, just kind of use the group as a sounding board to get ideas, get resources, work through problems, troubleshoot, stuff like that. So so yeah, we're all kind of working independently together. And it's been, yeah, kind of a cool just place to get some face time and talk through our own learning journey. So yeah, anything else you guys would add?
Maybe for additional context, so this started out as a group focused on cadCAD 1.0, and it became clear in the first few weeks that cadCAD 1.0 wasn't quite ready for prime time. So I think that sort of led to some of the focus on system models. And for the coding work that I've done, I've been working on, I think it's version 0428 or something like that, whatever the current base release is. in terms of implementing models.
Yeah. Yeah, totally. So I guess the original intention to like center cadCAD 1.0 as the topic for the group, we've kind of like strayed from that a little bit just as the release has gotten delayed. But I mean, we've all kind of found our own valuable topics to learn on or to work on, and yeah, even using older versions of cadCAD in replacement. So hasn't been too much of a roadblock. Cool.
Yeah, good. Yeah, it's great you guys are doing this. Yeah, thanks for the context. And yeah, I mean, I'm just as I'm of course very antsy and want to jump into cadCAD 1.0 myself, but yeah, I actually typically run 0.4.23 just for reference, just because a lot of the models that I've been working on like were older than that that latest release, and also like that you'd find probably ran into like running some of the demos that they were really they weren't refactored for 28, just for your reference. But I'm sure you probably already ran into that.
Yep, I've been on that journey.
Yeah.
It seems pretty straightforward to update them, at least the ones I've updated. You just have
Yeah.
to change how the experiment gets set up.
Exactly. Yeah, it's like 2 lines.
Nice. Well, yeah. So I don't want to put you in too much of a spotlight, Barlin, but I know you want to stay anonymous. But maybe you could just like give a quick hello and intro, like what your work in token engineering has been like, how you're involved with cadCAD, Block.Science, etc.
No, I'm not going to say anonymous.
Yeah, I get it.
It was one of those like universal Discord things. Like I was trying to be anonymous in one channel, and just like, and that didn't work anyway. So whatever. Yeah. So I've been with Block.Science since nearly the beginning, or probably the beginning, and as well as from the outset of designing cadCAD 0.0, in terms of like being like really defining what a scientific Python environment would look like for the type of work that we expected to be coming down the line. And not that cadCAD is what you guys have seen. It doesn't have to be like everything is crypto, although that's kind of the world we're in. It was really built for being able to do state space modeling with this like separation of essentially like agent actions, as well as agent or policy level inputs that update the state. So like in a nutshell, that's there's that separation there, and then then it's built to be able to handle the types of experiments we'd like to do, like really kind of scientific experiments of just being able to do the Monte Carlo simulations and parameter sweeps and that sort of thing. So, but yeah, so I'm technically the lead systems engineer at Block.Science, and my background was in designing ships and solving large-scale logistics problems around ocean-going logistics, and then a lot of data and both design and solving those problems, both like actual modeling, physical modeling, as well as doing essentially simulation and modeling for ship design prediction. So that's basically where I came from, and I certainly pretty lean towards that, like that system design, system architecture, being able to really kind of map those things out. So that's there's better Python coders than me out there, but the kind of the systems view and systems thinking is what I've done quite a bit of.
Cool. What's your formal education?
So it was a bachelor's in naval architecture and marine engineering. So that's really the undergrad for being able to design anything that floats, as well as the engine systems and all associated like engineering systems, so electrical, mechanical, piping, all those things. So that was my undergrad, and then my graduate degree. Always love something to name drop a certain number one engineering university in the world kind of name, but it was ocean systems management in the ocean engineering department at MIT. So I was doing the logistics and finance and economics, and like the solving the large scale logistics transportation problems. So that was my master's.
Cool.
Yeah.
Awesome. Interesting. Like, it's always interesting to see where token engineers did their formal education, because it's usually, it's always something that's not token economics or blockchain related, because that happened. They went through the education system before that. So,
exactly.
Yeah, very cool. And hey, Ratio 13, thanks for joining.
Hi, how's it going? Thanks for having me.
Yeah, cool. All right. So, anyone else have any questions before we get started, or comments? Cool. All right. So, I believe I was first on the list, actually. It's always a race to sign up first, I know. I usually win. No, actually, I don't. I think Zane usually wins. But yeah, so I'll get started for today. I am trying to multitask and double check, but I keep clicking the wrong link. Yes. Okay. And Quiet Catalyst, you didn't sign up. Do you think you want to take some time to talk about your topic today?
I may. Yeah, I've got some updates. So.
Cool.
Okay, jump in. Yeah, I wasn't sure if I would. I was actually just working on it before this meeting.
Okay. Nice. The best work always comes in the final hour.
There's still more work to be done. Pretty sure where I am.
Yeah, totally. Okay, cool. And I think Barlin is going to join for the first hour. So I'll go quick, and let's just jump right into it. So my learning journey is this one. So applied token engineering process. So for some quick context, I also have this learning journey called the predator-prey model, which is now my previous learning journey since I started this new one. But basically, I started that model and then kind of realized that I wasn't actually that interested in the model. It's like a fairly common starting point for some of these topics, but obviously I'm not particularly interested in predator-prey interactions. What I was more interested in, I realized, was actually applying the token engineering process and just getting some iterations working through that. And so I kind of zoomed out / changed my topic just in the last few weeks. And yeah, so that's kind of what I'm talking about now. So my learning goal for this study group is to apply what I know about the token engineering process to beginner level systems and gain a better understanding of how the process looks and feels in practice, since we've heard many times that it's an art. And also just get a feel for some of the prerequisite knowledge and skills needed, and eventually moving on to token economic systems. So I'm kind of starting with the predator-prey model, which was my original learning goal. And then I'll probably pick another second or third model just to get some more iterations on it, and kind of go from there. But yeah, and my plan at this point is to create some deliverables that are like a template for evaluating systems and preparing them for development, like these beginner level ones, just to give people like an intro into the token engineering process. And then obviously I would have completed 2 or 3 of my own models with some notes and documentation as sort of examples that people can refer to if they're curious about applying the process themselves. And hopefully some small library of resources that I find helpful along the way. So that said, I did make some progress on the predator-prey stuff this past week. I'll kind of just go through, top to bottom. So the template that I went with for applying the token engineering process is basically split into 3 phases. And I guess I collected these phases these 3 phases and then the underlying structure just from what I have seen or read in the token engineering space for the past months or whatever, participating in some of the Token Engineering Academy courses. So that's kind of where I got this template from, but just kind of applying it for one of the first times myself. So starting with the discovery phase, and then the design phase, and then the modeling phase. So I think this actually is probably really familiar for you, Barlin, because I think this is the same 3 phases that Block.Science used or has used. So those are the 3 phases. And within each phase, I have sort of subtopics. And basically, what I had done before was just sort of start from a random point and then I was working on the predator-prey model. I did some stock and flow charts, and I had like this lucid chart going, but there wasn't really much organization to it. So I took a lot of what I had done and tried to fit it into this template and see what parts of it I had covered or missed by just starting randomly as I had before. And so I realized that I never really set a system goal. I kind of had, I don't have it up right now, but I had like, I had some questions I had some key, what did I call them? I had some hypotheses or questions that I wanted to dig into, but I didn't really have a system goal. So I sort of created that, which is sustain the populations of a predator and prey in an ecosystem. And I turned this into system requirements. So predators can always find prey to eat. The prey population never drops to 0. And I heard someone on mute.
Yeah, I just had a question with something you said before.
Yeah.
When you were saying you were starting from a random point, did you mean a random point in the process or a random point as the initial state of the system?
In the process. So I didn't really apply the process yet. Here, I'll actually see if I can just show my. So I didn't start with, when I started my original learning journey, I didn't actually start with applying the process. I started with the model, I started with the system, the predator-prey dynamics, and then just like, sorry, I'm trying to think and use my computer at the same time.
No problem.
Okay, so I'm always a little fried at the end of the day too. Okay, screens, that would help a lot. Okay, I'm just going to share my second screen. Cool. So yeah, when I started, it was basically just this on Lucidchart, and I said, like, I put some questions down, and I started with some assumptions. I wrote down a few initial conditions randomly, had some ideas about how I could add complexity, and then I went ahead and started designing or mapping the system out with some tools that I knew about, which would be like causal loop diagrams, stock and flow, and then, pulled the math specs from Wikipedia, which was convenient that they existed already. And then I ended up actually plugging it into Excel and creating some simulations and discovered a few insights. But what I actually found was that after I took what I had done before, so sort of that random process, and and fit it into the token engineering process, I actually learned a lot more, which was kind of interesting. So I was forced to sort of create this goal and these system requirements, and then these were the diagrams I had made before, but then I defined the variables and went through the design phase a bit more. Most of this, I guess, I had already completed or stolen from Wikipedia in the design phase. But then it was sort of this modeling phase where I actually started to learn some cool things about the model, or about the model as I had set it up. So I started out with just like a basic question of, does my model satisfy these requirements, so system requirements that I set? And I guessed yes, and was looking at the simulations that I ran in Excel, and I actually definitely didn't fulfill the requirements, because they both, or at least in 2 out of the 3 runs that runs that I had, both populations eventually dropped to 0. So I definitely didn't build a model that satisfied my system requirements. And so that was like an iteration of the process, which I thought was really cool. And then I was like, okay, well, how do I fix this? What do I need to do to solve, or to realize those requirements? And I used the differential spec, actually, that Zane showed us in the last call last week. And it ended up helping, because I realized that I didn't set up the formulas in my Excel sheet correctly. So like very beginner error, but when I was building it out or representing it like this, I realized that one of the interaction parameters was not set up correctly in the Excel sheet, probably because I just tried to do it all in one cell, and it's just like hard to see visually the formula, so the formula was actually wrong. And after revisualizing it like this, I was able to identify the issue and rewrote the formulas. And the other thing that I noticed was that the system was quite sensitive to the initial parameters and the timescale. So I actually stole the initial parameters and timescale from one of the cadCAD models that exist. So that helped get me started on the right foot, actually. And then I ended up running these simulations, or getting these simulation results, which were a lot more dynamic and sort of interesting to look at, although they still don't quite satisfy the system requirements. It actually, the predator population is actually not at 0 for most of this. It's at like 1, but eventually I think in this area right here it drops to 0, and then obviously like there's some volatility near the end of the simulation. So I got closer by doing an iteration of the process and like testing my system requirements. So that was pretty cool. And so I guess I'm just gonna keep trying, or try one more iteration, see what happens, see what I can figure out, and try to get the ecosystem to sustain itself for longer. But yeah, that's mostly what I have to show.
I mean, I'd say your learnings, like I think you found by running the model, by creating and running the model, like how you're learning about how this works. Like even when you say like made that mistake, right? You saw that the computer was doing what you told it to do, right? Mm-hmm. So I think. So there's certainly value in that. I think that's something that we all need to remember, that there's value in the creation, and then like the person that does all the experimentation. There's a lot of stuff that you just immediately absorb, versus like just being voyeuristic and learning, like, and just watching someone else's results. So I think like. You gain a lot of value, so like don't discount mm-hmm. going through the process, even if it's not not where you want to be just yet. And then like there's the obvious mathematical things happening here that like obviously like these rates are highly like number one, they're purely subjective at this point because you're you're deciding for yourself. But because they're often I didn't actually look at your differentials, but they're I'm sure they're exponential. So like that means that they're also have that very high degree of volatility because of just the differential is very high. So exponential. So like that's why we often have with things at the 10 to the negative 2 or 3 or 4 rates in differentials, and still creates extreme decays and growth. So so like kind of this is where looking around in that space is difficult. That's where like this is where you would say, okay, well now I'm going to do a parameter sweep on and hold one of those rates, or like I mean they're all pretty. You could do it like pretty methodically, like you have 4 rates, and you could hold one or hold 3 of them constant and do a sweep over one, and pretty quickly do it over say like a roughly coarse window, say of like order of magnitude like 0.001 and like 1 to the negative 2 and 3 and 4, and then do like a more fine experiment. But then then the next thing, like once you're kind of like getting comfortable setting up those parameter sweeps, then you can do kind of the Cartesian product parameter sweeps where you could have, okay, like now that I've kind of learned what these rates look like in order to have some chance of surviving, or meeting your system goals, then you can kind of now do like a bigger sweep over, like all the rates and kind of each of their potential optimal sweet spots,
Yeah.
So.
And I had a quick question.
Yeah.
If I can interject. So about the parameter sweeps, what typically do you do to say how much a variable like explains like sort of the experiment? In your practice, what has been the most useful? Has it been to visually look at the parameter sweeps and kind of infer it, or has it been to math it?
Yeah, that's a good question. It really depends on the nature of that parameter. If we're talking about, it's like, in this case, well, I'd say, in some respects, what Peter's been working on, like I said, like they're subjective, but they're not, because like they are, like if you were doing this, say like an actual population, and then you were actually say mathing it, right, like actually getting the numbers. In like the things that we do, again, I go back to the nature of the parameter. Is it an assumption about agent behavior? Well, that's pretty subjective and never going to be like say like a determinant, whether it's not going to be deterministic, and it's also not going to be subject to like a centralized control or any sort of system policy. So those are like those assumptions say about populations of agents and what they might do. Those are pretty subjective. If we're talking about say like a parameter that's actually in the state space of the blockchain system, like it's a control parameter or a centralized parameter, say of an AMM or something, and that's very different, right? And that's where you might use the experimentation to look at some of those trade-offs, but then you may very well find yourself doing a couple things. Like one, if it is an optimization problem, then then you're going to analytically solve that. But we don't often have necessarily, again, because of the nature of that undetermined population agent dynamic, we don't often have that closed form optimization solution. The other, one other thing I was going to say, this workflow also about this, like doing these parameter sweeps, and as I mentioned before, doing these like Cartesian parameter sweeps also allows us to do. We have a workflow of Block.Science about like it's called parameter selection under uncertainty, where we essentially use a pretty simple machine learning algorithm over the set of parameter sweeps that we're doing to essentially classify which parameters are actually valid, valid for the solution space. Long story, but yeah, like the main answer is it really depends on what the parameter is actually, what is it holding a variable for.
Albus, could you mute?
Hey, Elbeth, could you mute? Awesome, thanks. Cool. Yeah, I appreciate the comments. I think pretty much what you said is what I took away. It's like applying this process actually helped me realize some of the errors that I had and learn from them in the sense that like I was able to fix them. But yeah, it's like a really sensitive model, I think, and so just being able to do the parameter sweeps would be really helpful in like finding a starting point that gives you some like even readable data. But I guess I ended up stealing that from a model that was already built, so I could see how that would be a challenge without something like cadCAD if the model didn't exist already. But cool. Awesome.
There's also a library out there called SHAP, which I don't remember what SHAP stands for, S-H-A-P, that I've seen used with classifier systems to determine the importance of different variables.
CHAP, like that? C-H-A-P?
H-A-P.
Wait, sorry, what did you say? C-H?
H-A-P.
Oh, H-A-P. Cool. Look into that.
And so thinking about that in the context of Block.Science, is there a possibility to add libraries to the Block.Science image if you wanted to add something like SHAP in there, or their ML tools?
Like cadCAD is simple just a library, and you can within the I don't know if you're asking like during runtime of simulation or.
I'm thinking in the context of running the simulation on the Block.Science platform as opposed to running it locally, because you could do it locally, but I'm not sure whether you can add to what the runtime environment is hosted. Because Block.Science has a sort of specified image that you're running the simulations in, right?
I think, I don't know if you're conflating labs, Block.Science labs?
Oh, I am. Should I not do that?
Yeah.
Okay. Sorry about that.
That's okay. It's not, I don't know if
not
it's
the
your
first.
fault with the name, with the naming that we've done. So Block.Science Labs is a separate company. spun out of Block.Science, but that is the hosting, yeah, like the hosted running of cadCAD. But it's really, um, it's not necessarily. It doesn't have to be cadCAD either. It is like really like hosted scientific environment. So I think
Yeah.
that's.
And so, are you working on the lab side or more on the Block.Science?
I'm an engineer at Block.Science, so like
Okay.
so I work on many projects for Block.Science where I often do use where I run cadCAD simulations where I create the systems and the cadCAD models.
Cool.
So like within like running cadCAD locally though, you can set up, you can bring in many things into your simulation environment and even like during runtime.
Yeah, because you're just running a Python app at that point.
Yeah, exactly.
Yeah.
Cool.
So
Awesome.
I built some models where essentially did a machine learning type algorithm, but I like wrote it. Didn't use I didn't use SciPy just because like we were actually really trying to do it closer to how the code would be implemented on chain. So like actually did it kind of like from its fundamentals. And so yeah, you can do that within during cadCAD runtime.
Cool. And yeah, I think I'll wrap up then because I want to give someone else a chance to present before the top of the hour. But Zane, I think, is sending, and I sent also some resources for parameter selection under uncertainty. So relevant topic in the Discord channel. Cool.
Okay,
so,
I'm typing into the
oh, sorry, Elbeth, I didn't hear you.
Sorry, I was checking if you said you were dropping that parcel in the Discord channel.
We just dropped some links about one of the topics we were talking about in the Discord channel. So the parameter selection under uncertainty.
Okay, thank you.
Yep. Cool. Then Zane, I'll pass it off to you. I think you are also signed up.
Okay, cool. So I am going to go kind of fast, leave a little space. Let's see if I have the right screen. Okay, cool. So my project is called Pico DAO at the moment. And so basically the premise is how can we sort of think about open source economics if we had like actual like sort of open economies. So instead of having any sort of like dedicated pool, like could we create just kind of open incentives like a sprint budget to allow various people to sort of contribute for that particular time period? And like, how do we sort of like go about like modeling that? So if we look at the like very small casual loop diagram, it's not detailed. The macro view is essentially projects start by someone saying that there's a product need, and that's like either a founder or a core team, and this kind of feeds into pending goals set for the project. And these pending goals take resources or development incentives. And when there's demand, there's more development incentives like sort of feeding in. So these development incentives encourage active participants. Active participants also reduce the individual development incentives per active participant. As you get more active participants, these kind of correlate with your amount of like achieved goals, which reduces the pending goals. And then there's this kind of delay here between the pending goals and the utility or evaluation. And so as pending goals kind of linger, utility or evaluation goes down, just either through like sort of perception or belief that like nothing's happening with this project, it's stale. But on the flip side, as you achieve goals, you produce a better product, which increases the sort of utility and valuation. These move in the same direction, which then increases demand, which then in theory increases development incentives. So that's kind of like the macro view of what this looks like. And then when we drill down, it looks more in reality like this. So to the right, we have these kind of funding processes. And these could be either VCs, these could be individual funders, this could be self-funded startups. And on the left are sort of the contributor processes. So these are the people that are contributing to the project with either their time or energy to make a product. And that product could be sort of anything, could be a podcast, could be like spreading vibes, whatever you want. And then sort of in the middle, that's the glue, is we have this idea of this economic black box. And this could be like your bonding curves, could be your liquidity pools, it could be your 10K TFP sales, and then your serum sale that happens afterwards. And so all of this kind of ties into these kind of loops. So very briefly and quickly, if we start here in the upper right with the funders, there's some initial funding. This goes into your total available funding. And the funders are willing to fund again as long as their expectations are met. So total available funding drives our willingness to make product bets. So you'll make a product bet if you know that you have the runway. You'll make a lot of product bets if you know of like a 2-year runway versus like one product bet if you know you've got a 1 month or 2 month runway. And then the other thing that kind of drives into willingness to make a bet is like your product needs. So in the beginning, you have no product, so everything is a product need. And that forces you towards making a product bet, which means that you're going to allocate resources towards that, which is like the available product funding, which then leads to how much you're going to allocate for like the month, the week, the quarter, whatever your sort of granular spread cycle is. This kind of feeds in, of course, when you allocate money to sprint funding, that reduces available product funding. So we'll go here towards the sprint funding, and sprint funding increases the individual monetary development incentives. So monetary development incentives entice new participants or new contributors to join, which will reduce the monetary incentives available. And then these individual non-monetary development incentives are the incentives that you get from being a part of a network. So for instance, being a part of, like, say, the TEC means that there's some utility in like joining that. And that utility comes from like sort of the people, the knowledge base that's within that network, all those things that are kind of like a little bit intangible that kind of relate to sort of experience. So we have these individual monetary incentives and non-monetary incentives that make up the development incentives. And then we have these old participants and we have these new participants. So development incentives drive both of these, but the relation between what they produce is slightly different. So a new participant is likely to be able to achieve short-term sprint goals. Now, old participants are able to achieve longer-term sprint goals and shorter term. Not only that, older participants increase the depth of knowledge within the network, which is different than the breadth of knowledge in the network. And here I define breadth to be the number of people that like know something about the product. And so there's a lot of people where this knowledge is spread. And this is like concentration of knowledge. So an example is to look at like the way that CoreGraph works. or not core Geth, but Geth itself. So if you wanted to change the way that storage works on Geth, you would need this depth of knowledge to be able to do that. But if you wanted to fix a typo, just having breadth of knowledge that's kind of shallow is like more than capable of sort of achieving one of these like goals. So both of these lead to better products, which increase utility. And utility basically drives whether or not the product has any sort of like unmet needs or things like that, which ultimately feed into um, whether or not the funder expectations are met or there's enough sort of demand. So as utility goes down, you'll have fewer users, which means less demand. Or conversely, if utility increases, you'll have more users and have more demand, and more demand feeds into this economic black box model. Typically, more demand is a good thing. There's in terms of like economic modeling, and then here there's a positive correlation that comes from this economic black box, probably to the total available funding. Okay, so that was like a huge amount of things. And so one of the things I've been sort of focusing on is how do you sort of take the CLD and condense it into a way where I can abstractly model the sort of contributor dynamics and these funder dynamics, and then I can figure out how to sort of draw the chords between the economic black box and the other sectors. So I'm just going to pull out of this, and then the kind of place that I came was originally going for building this differential spec, which kind of breaks down the processes. But then I realized that I hadn't really defined all the processes like well enough. So within this, I decided to break them down into their sort of discrete components, which I think will allow me to get to the point where I can model these sort of abstractly or a little bit concretely, but have enough abstraction to where I can model different token black box like economic processes and like have that be a thing. So really, I've kind of identified about 11 processes. And they're not particularly big. And like these processes then have different things. So I'll just go over the overview. So what I've started to do is kind of break the processes down into like their core sort of components and what it is I want to get out of that process, what data. So here we have the funder acquisition process, and this like determines the number of funders available for the pool, potential funders, etc. And then the kind of goal is to talk about number of funders in the ecosystem and the willingness to keep funding for potential subsequent funding rounds. So basically, I have a process that defines like how do you become a funder and what does that look like? So if we look at the differential spec, we have the number of funders that are currently in the system, the pool of people that could be potential funders, and then like the funding sort of satisfaction metric. And then here, as a policy or environmental process, we can then define how these three factors map to producing this kind of output, which is like the number of funders and like the number of remaining sort of potential funders. Okay, so I'm just gonna like stop there because I don't want to take too much time and just get some sort of feedback on like the process. And then I kind of had another sort of question about yeah, just I guess yeah, curious to hear feedback on what you think of this like process and like how you've gone about sort of abstracting things in a way that's more sort of like portable in terms of um, uh, drawing out these kind of relationships?
Yeah, so, yeah, really nice job. Yeah, certainly going through that and, like that all, I'm sure, again, kind of like all that you went through to really kind of think through all of those causal loops. I'm sure, got you thinking pretty deeply about your system. Yeah, and certainly, as you're going through this, I'm thinking about this, and some of the things that I would be looking to do would be like, yes, number one, what loops do you maybe not necessarily need to model or be able to essentially find, say, like outside of your system boundary, and could be, say, like whether it's a known process or whether it's not actually part of your system state. Like that you might find like a loop in there that like is essentially almost I want to say like purely dependent loop that maybe not that doesn't affect everything else. So like there's potential there, which you may find pretty quickly, or I shouldn't say pretty quickly, but there's a chance. So like one of the things that you could do with something like this, you could use Loopy, but sometimes it's pretty good for something like this to see those dynamics pretty quickly. If you used Loopy, you could.
What is Loopy?
It's basically like a pretty quick GUI for causal loop feedback with a Y. Yeah, that tool right there. Yeah, and you can spin this up pretty quick, and so it might get you to see that it's it's a GUI, so it's not as scientific, but it might get you to see some things pretty quickly. So that's definitely like one thing to look at from the more kind of scientific side, and how you're going about building this. I would certainly steer you towards making sure when you're doing this, that because you've identified like these sets of loops, I would take those, and the way you've kind of broken it down in your differential spec is nice too, but then really take those and think of them a little bit as individual cadCAD models, and make sure that you do a verification of each one of them. That makes sense, like that, so that it passes like your verification test of like, okay, I expect this to happen. This is what's supposed to happen. If I abstracted everything else away, here's what should happen, and run that test. And that way, before you get to the integration of all these loops together, you have each one of them, like correct, as if you cut off, you made like a break from its like external loops of like the way you've gone kind of like to identify these, like kind of almost primary loops, or like like these loops that are essentially like kind of like a handful that has like a pretty small amount of boundaries outside of itself. So like like one of the things you do in systems is like you kind of draw a boundary around that system and identify like where, even in what are called closed systems, you still can have identified inflows and outflows, as long as like those are well defined. You can still kind of you can consider it a closed system. And in this case, like it seems like a lot of these you could make as closed systems, and so like that's how I would kind of go about making those verified models for like kind of the handful of kind of like primary loops that you have there, before you then go and integrate them.
Yeah, I think
What you'd
that,
be doing is like taking, like you'd be making essentially like smaller cadCAD models and then just plugging them together, which is exactly how the architecture of cadCAD was set up to do anyway. Like, by having just adding more of those partial state updates into your partial state update block dictionary. So like, those are my main set of recommendations.
cool. And then I guess a couple of like non-related questions. So I guess there are a couple of things. I guess like where do you find yourself drawing the boundaries between sort of agent populations versus like sort of larger like just kind of like stochastic preferences. So um, what should be an individual preference versus what should be like, oh, the population like comes out with this kind of particular distribution versus like I guess top down versus bottom up.
Right. Yeah. Yeah. So what you can do is, it is a little bit about where you want to start, right? Like of whether we say, oh, like, we're going to have 50% of the time we'll have an agent that just kind of, does this like moderate action or whatever. And then these others coming in and say like what's a different risk profile or whatever. Or you have these individual agents that you're designing, that is going to do this like one specific attack or something like that. So what I typically do, like, I mean, it really kind of depends on the nature of the work and really in the nature of the model, like the granularity of the model is, is it a block or a transaction level model within a block, or is it like some long scale, forecasting performance of an economy. So like that's where you might so the second example you'd be kind of more looking at population dynamics versus the first example you'd be looking at, okay, like what are these exact agents going to do? And then like really the mix though is we do try to say, when you're say doing a population dynamic model, you're still drawing from some distribution. So like that's where you can still have, like, I mean, I typically would still have this stochastic vector in that draw. So like you could either have like where if they're taking an action, I always like an easy thing is like they could, even if their action, say, is determined based on some preferences of the system, say, at the time, but like, the magnitude of their action or the magnitude of their ability to act, say like a draw from like a simulated wallet size for that particular population at the time.
Do you have any good resources for that topic, or like even just keywords to like start searching around on?
So certainly, I've some models that I believe are open source, but I think it's certainly is population dynamic modeling, and I like even if you went into there, you would see
Cool.
that it wouldn't be like wouldn't be making say like deterministic populations. You would be doing some sampling. So yeah.
Awesome.
And then I guess sort of my last question, to be really brief, is what kind of pro tips do you have about this, like sort of testing and validation of the models? So I know some of the models will like go around like modeling like market price, etc. And then I was just kind of curious, like if you had any thoughts about that.
What was like the first word? I just didn't catch the very first word you said. You said like, what are the?
Oh, I guess just in terms of like validation and like testing, what would be like sort of your pro pro tips for like
Uh,
going through that process, or
yeah,
things
so,
that have gotchas?
right. Yeah, so, I mean, like, the first set, I don't know, Peter, who showed them, like, the verification and validation V, but that's where I was going. You can probably find that from many of our slides, but, so where I wanted, my first kind of set of recommendations for you was to go down, like there's a V that we use for like really system design, and so like going down the V is the verification side, and so that's where that's where I was recommending you go first, and make sure that you have like your system verified as you've defined it, with like all those really almost like it's your determined expectations, like okay, like this is how I'm saying this is going to work. Does it work the way I've said it? And that's that verification side. And then as you come up the other side of the V, that's the validation. And that's where you're saying, okay, that's where you are making some assumptions at this point about, say, maybe it is about population dynamics, or agent actions, or even say like there could be an external process here, like say like the price of the dollar or price of Bitcoin, whatever, or their relation to each other, and you're doing some validation tests, say against whether it's stochastic processes that you have about populations, or whether it's a exogenous stochastic process that could affect like your internal economy here. So like that's where you're running those validation experiments against, and say, okay, does everything that I've already said should still hold, and does it hold, say, against this Monte Carlo simulation about like say Bitcoin to dollar time series, those sorts of things. That's where you're doing the validation, but you are making those assumptions about what are the things that affect your model, and your system. So like are those internal things, or are those external things, and that's what you're trying to come up with, so the things that could break it and break your assumptions.
Cool. And I guess like the kind of follow up is like when you're modeling market like pricing dynamics, do you tend to use Berwinian motion, or are there any sort of things that you particularly tools that you like to like use to accomplish that?
Yeah, it really depends on, again, like kind of on the nature. Certainly that's one of the things we would use. Really, if it's the nature of the system, if it's like a kind of like a nascent crypto system, then that's a little different, right? Like then we might use I typically use, say, something like where there's some kind of like normal Brownian motion market dynamics, but then I usually like to throw in a Poisson process for shocks. So I kind of have like an expected like arrival time of like how often shocks are going to happen to the system, and see what happens there. So that's usually what I do, is that combination. So almost like kind of like a series, it's a combination of like the low amplitude, high frequency, like essentially driving process with this occasional high amplitude, low frequency, if I said that right, like kind of shock to the system. So that's usually what I like to test something like that against.
And do you have situations where you have to calibrate to historical data to keep those assumptions in line? I mean, thinking in the world of tokens, you could be looking at the chain and see what's happened in the past and try and set some of the parameters based on that.
Yeah, so I have done that too, yeah. Um, so you can do that. Yeah, you can do that within, if you're during runtime in cadCAD. Like, you could read in a historical data set. That's not a problem. And are you talking about, let's say, like doing essentially a fitting exercise, or where you're actually doing like a dynamic control of your system?
I was thinking of it in two stages. So fitting against historical to set parameters that would be used in simulation.
Yeah. Yeah, so you can, so the short answer is yes, you can do that. And yeah, I've done that. Yeah, you can like read in the CSV like pretty easily if you want to set it up that way, within running your simulation, where it could like be reading in like, say, the new day and doing some update, even a machine learning update on, say, like, the new day or the new block, to update and control. Yeah, that's not a problem.
Nice. And Barlin, I know we ran a bit over the hour, and want to be respectful of your time. So I'll give you. I think maybe I'm sure we'll continue the discussion. I don't know if cadCAD plans on presenting or not, but if you do have to drop out, I just wanted to give you a chance to. But otherwise, yeah.
Yeah. I can do like 10 more minutes.
Okay. Awesome. Yeah.
Well, then I'm going to stop streaming and give the floor.
Or well,
I want to.
Yeah, cadCAD, did you want? I forget what you said at the beginning. Sorry. Did you have stuff to show off?
Yeah. Let me see if you can share my screen.
Awesome.
So if you remember from last time, we were talking about bonding curves and doing simulation against that. And I had taken an example. An example of a sigmoidal bonding curve and paired that with just some bare bones cadCAD simulation. And so in the past week, I've sort of restructured it so that basically with these settings on the top here, these two blue curves, that's sort of governing how supply and pricing is going to work, and then how supply and collateral into the system would work. And so I've set things up so that now we can observe what happens in agent participating in the market. So it's as simple simulation as I can think of at this point, just to kind of test these things out and see how it responds, with a longer term goal of making it more sophisticated and seeing how does behavior play out over time under different assumptions for how these curves would look, and sort of in the back of my mind thinking about what does this uncover about the nature of the system if we can explore some of these behaviors over time. So looking at what's happening in the market, and I'll caveat this by saying I think some of these plots are not correct, but I do think the market circulation graph is correct. What's happening here is, like I said, I've got the single agent set up to, right now it's just set up to buy as long as it has capital to spend, basically. So maybe if I scroll down to the bottom and show what the agent is doing over time, at the bottom left here, the agent starts with a pool of capital. And so as long as it has capital, it's going to buy tokens. So the green line shows capital declining as it's purchasing tokens. Each step along the way, it's purchasing one token. Actually, intuitively, I think capital is declining a little too quickly here, so that might be one of the things that's not correct about the plots, but the general idea looks accurate. Capital declines as you buy tokens, and then it hits a 0 point, at which point the agent decides, okay, I'm going to sell a token because I don't have any more capital. And so it oscillates for these last, 25 iterations or something like that of the simulation. And you can see how it's building up its tokens over time as it's going through the purchase cycle. And then it sort of oscillates out here at the end as it's going through this buy-sell cycle. And then similarly, what we see in the market dynamics is tokens in circulation, starting from a 0 point, is being driven by the purchases of this single agent, and then starts to oscillate as the agent goes into that buy-sell oscillation. So maybe a question related to cadCAD. I find that for passing information around, generally packaging things into the data structures provided by the cadCAD framework and using those to pass between the different update methods and things for updating variables in the system. And is that sort of in line with best practices for cadCAD?
Well, I didn't see, like, I guess the first part of your statement, saying about how you're doing it, but I don't.
For example, if we consider that the system has a market and the system has an agent, then information about pricing, for example, will come from the market and be packaged up into, I think, a state variable, if I remember right. It gets passed through the cadCAD framework into methods defined by the agent, so that the agent can see what the price is in the market.
Yes. Okay. Yes. Absolutely. That's correct.
Okay.
Yeah, and then like, yeah, what we do, like in this case, I think from what you have, like that would be correct. Like that would be like an obvious system state, or really like a metric about the system state where it would be a price. So like that would be known for everyone. Versus say like, you know, and some more sophisticated things, you might have like agents that are, say, doing their own computations or have their own like private knowledge about something. That would be different. But it seems like in this case, like, you know, like you're identifying like this agent preference is over, you know, a public, you know, essentially a public metric about the state of your system. Yeah. That makes sense. So is it because of the sigmoidal bonding curve that they can just, as they enter in the buy and sell cycle, they actually gain tokens, even though they're not actually injecting more capital, like you see like the corresponding
out here. So they gain capital back when they sell. I'm not sure why the trend out here
That's what I'm
seems to be
asking.
rising slightly as opposed to sort of staying flat. So there might be a...
That's what I'm wondering about.
Yeah. This stuff is very fresh. I was working on it.
About 2 hours old.
Well, how come it's not 100% right then?
But it is progress, and so yeah, it's some very basic pieces in place. I'm definitely on the left side of the V in terms of just trying to sort out, are the pieces doing the things that I expect them to do based on how I'm defining the model. And then ultimately, this can go to some of the more advanced scenarios where we have different parameters governing buying and selling tokens. So we'll have different curves for buying and selling, and then that'll impact. So this is not implemented yet. You can't see how the sell curve impacts selling at this point, but something to bring along as I take it forward.
What are you using here? This is
Visualization.
Yeah.
This is Dash. It's a Python framework that basically wraps Plotly and wraps it with an HTML framework so that you can make one-page applications out of it.
I'll have to check that out.
Yeah, it's really cool.
Yeah, thank you.
And so I kind of forget, so is your plan to like run simulations or run experiments to see how agents behave with different shaped bonding curves and different taxation plans and everything? Or like the inverse?
It's sort of a duality.
Mm-hmm.
So you can set agent behavior, and I've got an example of this where the agent behavior can be more stochastic. So right now it's just set to one token, so I can do some simple testing. But we can randomize agent behavior. We can have multiple agents. I think what's especially interesting to me is how does the market play out in real life as compared to these definitions when agent behavior is variable. So you have buying and selling taking place in different ways. I think this actually ties into the whole Luna Terra meltdown that's been going on. I understand they ran, I don't know, millions of simulations, but apparently one of the things that was missed was understanding the volatility of some of the actions. And so as the volatility moved in a way that was unexpected, the system did not respond in a way that maintained its overall health. And so they're trying to figure out what to do about that.
Yeah, need proper token engineering.
Yeah, exactly.
At least we learned something out of all that value disappearing.
Yeah, that's an expensive lesson.
Yeah.
Excuse me, please.
Yeah, so I do have to go now. Yeah, this is really cool to see.
Awesome.
Everything you guys been working seriously. Like, yeah, I think it's really good.
Yeah, really. Thanks a lot for joining us, Barlin. Yeah, really appreciate volunteering the time and the knowledge. Helpful to have.
Thank you.
Expertise. So.
I'd like to do this again in a couple of months and see how you guys are getting on.
Cool. Yeah, we'll keep working.
Awesome.
Awesome. Yeah, we'll see you around. Thanks, Barlin.
Oh, Bonnie. Hello.
Yeah. Hey, Elvis.
Okay. Sorry, I wanted to find out if cadCAD is based on agent simulation as well. It's classified as agent-based simulation.
Yeah, I think it can do. I guess it can do both. I mean, cadCAD itself is, more for just modeling complex systems, but you can create agents within cadCAD, and I don't know, Quiet Catalyst, you probably have a better answer to that, but I would just say it can do both.
Yeah,
Okay.
there are some examples out there which use, I don't know how many agents, at least 100 agents in the simulation. There are probably some that scale to more than that. And I think one of the challenges in doing that is how you structure the system so that, one, you're managing the agent behaviors in a way that doesn't get tangled up with the overall cadCAD framework, and then two, you've got an update mechanism for the agents which fits within cadCAD. So that's actually on the list of things to get to is adding more than one agent to the system that I have, and then being able to have different agents exhibit different behaviors and manage the updates of individual agents so that each agent gets updated appropriately based on its behavior.
Yeah, I feel like you would run into challenges of what information does the agent know when they're making their decision, and do they know the actions of other agents? Is that kind of the trick? Like,
Yeah, and so from a coding perspective, it's very much around the notion of separation of concerns and
Hmm.
what information is available to what pieces of code.
Yeah. Hmm.
And I've probably been through 2 or 3 iterations on um, how that looks right now in what I just showed you. And I actually, so just this morning, I was refactoring stuff to pull. I'd originally implemented so that the cadCAD data structures were being passed into the code that I was using as the agent, and I've pulled that out so that there's sort of a cadCAD layer, and then there's an agent piece that has only information that's specific to the agent. So the cadCAD layer will pass in, for example, the market buy price to the agent, and the agent can make a choice: do I buy or sell?
Hmm. Yeah, that's really interesting. I know we kind of like go high level and look at the pretty UI when you present, but I'd be curious to go into the code and like see how you yeah, move the information around with multiple agents once you have that figured out.
Yeah, I think that'd be a good future topic, even for as simplistic as it is. If it's helpful to look at the code as currently structured at some point, we could do that as well.
Yeah, yeah, totally. I mean, I like personally don't have the skills to build very complex models myself, so I can at least learn by looking at something that's been done. So I'd be interested in that.
Yeah, definitely cool. Taking a lot of inspo from that dashboard. It's like,
Yeah,
oh yeah, I definitely want to do more of that.
yeah, yeah. It's
It makes pretty pictures.
so much
There's
cleaner.
still, I've got some things to clean up in the layout, but it helps a lot in graphing.
Hmm. Really cool. Um, was there anything else you wanted to touch on for your topic like Catalyst?
No, that's it for today.
Cool. And Elbeth, thanks for joining again this week. I just wanted to check in and see if you were still working on a topic, or had questions or comments or anything.
Yes, I'll double up. I've been lazy. Apologies for that. But I'm getting more understanding coming around, and the challenge where I have is where what you drop, that is differential specification. It's kind of challenging for me to get the differential equation on the ones, but I'll give it more time, go over those materials, and I'll present something next week.
Mhm. Cool. And yeah, I mean, even if you want to work through it live, we could try and do that at some point in this session. I mean, for my topic, like the differential specifications for the system I was looking at were basically given on Wikipedia, so that was nice. But yeah, I can imagine it's a lot more challenging or requires some creative thinking to do it on a system that you're creating yourself. So I'm sure we'd all learn something if we tried to work through that problem with you. So maybe we could do that next week if you don't figure it out.
All right, I'll bring it next week. Thank
Awesome.
you.
Cool. Yeah, and just sign up on the one-stop shop or that page, the sign-up page, if you want to reserve time in the end, just so we can prepare in advance too. But cool.
All right, I'll do that. Thanks.
Nice. Um, all right. Well, I know we also kind of rushed through the end of yours, Zane. Did you have anything else you wanted to mention? Like any plans, like next steps or anything?
Not really. I would say probably my next steps is like I kind of hit I think the same sort of uh, issues that Quiet Catalyst was hitting, just about like organization and separation of concerns.
Mhm.
So like when I was doing the differential spec, I realized I had like all these little baby processes. And it's like I just need to know what all the processes are. So I think probably I'm trying to get to a point where I have all the processes laid out, and then I can like start writing little models. So
Mhm.
hopefully I'll use something with Dash and start modeling like the individual processes before I put them together in like one sort of mega Voltron or
Yeah.
Robotech type of
There's a technique
robot.
I saw in cadCAD hacks, which looks like something really useful. I haven't had an opportunity to actually implement it in the stuff I'm working on. But basically, they had a chain of partial state update blocks and added just a variable in the dictionary to say whether this element should be included in the chain. And then when they configured the experiment, just did a simple loop over all the elements in the chain, and if that flag was set to true, it got included. If it was false, it didn't. I was thinking that would be really
Huh.
useful for sort of a unit testing approach where you want to have just certain pieces in the simulation for testing.
Nice. I'll have to take a look at that. You said it was in the hacks at one
Yeah,
point?
I'll see if I can dig out the specific hack because there are 24 of them at this point. I'll post it to the chat.
So,
Okay, if you
so
find it, you find it. Otherwise, I'll keep that in mind.
Okay.
is it like a parameter sweep for like model sections or like model segments, sort of? And like that, it doesn't actually change parameters, but it like
Yeah, exactly.
it activates or
basically it says-
deactivates parts of the model.
Yeah,
Yeah.
that's it. It's activate or deactivate.
Cool. Nice. Yeah, and then Zane, the other thing that Barlin said that I thought, or that I at least remembered, kind of stuck out for me was like trying to identify if any of the parts of the causal loop diagram, while they're important and relevant for that diagram and for the system overall, but maybe they might not actually be part of the system state and maybe don't need to be included in the model. So maybe it could help to like create a stock and flow chart of the system and see like see where the stocks are, and yeah, and then start like working through the design phase, I guess, just thinking back to the TE process that I had lined out. So like in the design phase where you have to define your variables and the state, then that is what would, I guess, move you closer to building a model and prevent you from modeling or building parts of the model that don't have actual impact on the outcome. So maybe that would be just another another exercise.
Toolkit.
Yeah.
Yeah, definitely. I'll have a look at that. I've been curious about it, but I've been like sort of questioning the like sort of utility of that versus like the differential spec. But I think kind of what happened was during the like differential spec phase, I realized that like I just have like not a clear picture of all the processes.
Yeah.
So I gotta just like pull back and then go back to it. But yeah, there's a lot of stuff in the CLD not worth like quite worth modeling. Like there's a lot of like unmet needs types of things which are like not quite there. Yeah.
Cool. Awesome. Well, I think that might be all for today. Sorry the timing was a little tight in the end for Barlin. I know it was really awesome to have him here, though, just to be able to ask some questions. So hope it was still valuable, even though he had to head out a little early.
That was good. Unfortunately, all the questions I had prepared in advance had to do with the Block.Science thing. So.
The labs.
Yeah.
Platform.
Block.Science Labs.
Yeah. Yeah. So separate companies, I guess.
The wires crossed on.
Have you done the I think the Block.Science Labs team is like taking beta testers or something. Have you looked
Yeah,
into that?
I'm in that group.
Oh, cool.
Honestly, I haven't used it a lot, so I run a simulation based on one of their samples there, and so from what I can tell, the platform lets you apply your cadCAD code in a certain format to running in their sort of predefined server images. And then you can export data from there and load it into a Jupyter notebook for sort of downstream analysis and explanation.
Yeah. Cool. And do you have like sessions on that each week, or how does the beta testing program work?
So far it's been self-serve.
Mm-hmm.
So I just signed up for an account, and I everything I've done on my own. There's no training or anything like that.
Yeah. Cool. Does it feel like it's close product-wise? I haven't used it or anything.
I'm not sure. So,
tough to say.
The one simulation I did was pretty simple.
Mm-hmm.
Where my mind is with it, I would like to have some things like what I can do with Dash in the Block.Science Labs environment, as opposed to if the process is run a simulation, save some data, load into Jupyter, that's a little more cumbersome than I would like it to be. I like to be able to more dynamically explore through more of an application style interface. But that said, based on the tech stack that they advertise on the website, they've got some horsepower underneath there. So they're running Spark, for example, on the back end, which should mean they're able to run simulations efficiently. And so it's a question of, do you go create your own cloud instance to run your simulations, or do you leverage what they've built and run it through their system?
Well, cool. Getting a couple of cadCAD experiences then.
Yeah, it's sort of like having another perspective. And I get the sense that the team is pretty much heads down, because I asked a question about how to change the way files are saved on the system, and I think it took like 2 weeks to get an answer.
Yeah, I'm sure they are. A lot of high priority stuff out there, everywhere.
Yeah, it's all moving fast.
Yep. Cool. All right. Well, anything else for this week before we head out? I'm just thinking.
No, it's not for me.
No. Cool.
Yeah, nothing for me.
Cool.
Yeah, thanks for organizing and reaching out and getting Barlin to show up and stuff.
Yeah, no problem. I'll definitely try to get someone else again, and like maybe we'll go like every 2 or 3 weeks. Try and pull someone. I just know that there are a limited supply, and yeah, so they're all kind of like volunteering time, but they're excited that there are people studying together and applying this stuff and using cadCAD and all that. So yeah, they're glad to chip in when they can help. So nice. All right. Well, I think that's all then.